Hello, class. Today we are going to cover 4.4 laws of logarithms. Hopefully you're keeping up with the homework because as soon as we wrap up chapter 4, we will have our first test, which will cover chapters 1, 2, 3, and 4. So hopefully you had a chance to look at the chapter 1 lecture videos, even though you did not have any homework. Okay, 4.4, laws of logarithms. Okay, so in the previous section, we looked at some uh, properties of logarithms, which were very intuitive. So here we're going to look at the laws of logarithms, which are not as intuitive, but they play an important role as far as evaluating logs, and then also when it comes to solving logs. Okay, so we're going to let a be greater than 0. A is not 1. And we're going to let A, B, and C be real numbers. So they are real numbers with A being greater than 0 and B is also greater than 0. Okay. And this is because in this class, we are not taking the log of 0. We are not taking the log of negative numbers. Okay, so with this in mind, we have these three main laws. Okay, so we have this first one, log. A is going to represent any base. So here, if you're taking the log of a product, this first law says that you can take this single log of a product and you can expand it. And if you were to expand it, it would be equivalent to the log of A plus the log of B. Okay, and this is an equivalence, which means that the other direction holds as well. So that if you had log, here, let me erase this part. So even if you had just that part, if you had that, the sum of two logs with like bases, then here you could rewrite that log, that sum, as a single log of a product. Okay, so it works both directions, and you'll be expected to be able to, if you have the left side, be able to expand it so it looks like the right side. Or if you're given the right-hand side, be able to condense it so that it looks like the left-hand side. So be able to go in both directions. Okay, the second property, log of A, any base. And here you have not a product, but a quotient. Okay. And here, this one says that if you have a single log of a quotient, then you can expand it so that it says log of A minus the log of B. Okay. And I'll show you how we get this one from the first law together with this third law that we're going to take a look at. Okay, so here, so this next one, this last property states that if you have the log of A raised to some exponent, okay, this one says that if you have the log of A to the power of C, you can rewrite this by bringing down that exponent to the front and taking the log of just A. Okay, and again, be able to go, if you're given C times the log of A, be able to rewrite that as the log of A to the power of C. Okay, so that second law, the one with the quotient, is really just a combination of laws numbers 1 and 3. So here, I'll just show you off to the side over here. So if I have this, so let me give you an example. Okay, so if you have this here, so suppose you're taking the log base 3 and you have, let's do a to the negative 2. Okay, well, according to number 3, it says we can take that exponent negative 2 and move it down to the front, right? Okay, well, so now let's take a look at this one, where we're taking the log of base 3 of, let me do b to the 4th power, and let's do a to the negative 2. Okay, so here I have a product. One of them has a positive exponent, the other one has a negative. Okay, so here it says that if I have a product, I could separate them, right? And then it also says, so that's from the first law. Okay, and then from the third law, it says that if you have the exponents, you can bring them down to the front. Okay, so what happens is this second law is just a combination of 1 and 3. So let me just show you here. So here, a over b is the same thing as saying a b to the negative 1, right? That's what a over b is. A over b is the same as a times b to the negative 1. So if we use our laws here, first we have that product, so I can go ahead and rewrite it as a sum. And then now, from that third law, I can bring my exponents down to the front. And that's how come this one here, which is the equivalent of a over b, right? A times b to the negative 1 is the same as a over b. So that's where we get that second law, okay? All right, that's just sort of an aside. Just the important thing is that you are familiar with these 3. Make sure you memorize all 3 here. Okay, and we will need these for solving. Okay. All right, so let's take a look at how we use these laws for evaluating. Okay, so suppose that I need to evaluate this log base 3 cube root of 27. Okay, so over here, I can rewrite that cube root using an exponent. So here, base 3, and that's the same as saying 27 to the 1/3. Okay, and then here, I can use that third. So all I did was rewrite it, first of all. Okay, so if you have radicals, you want to rewrite them using rational exponents, meaning fractions, fraction exponents. Okay, so so now all I did was rewrite it, and now what I'm going to do is I'm going to apply law number 3, which says that I can take that exponent and bring it down to the front. Okay. And then here, I can figure out what the log of 27 is, base 3. And the answer to log base 3 of 27 is going to be 3. 1/3 of 3 is 1. Okay. Let's take a look at another example. Suppose that I have this log base 2 of 160 minus log base 2 of 5. Okay. So even if we could do this in our heads, well, log base 2 of 5 to what power is 5? It's going to be a decimal number, so that would be tricky to do in your head. Okay, so let's go ahead and use our laws here. We don't have any numbers in the front, so I can't rewrite them using exponents. Okay, but I do have a subtraction, and it says here, if you have a subtraction, that's number 2 right here. If you have subtraction, you can rewrite it as a single log of a over b. So over here, I can rewrite this as a single log of a, which is 160 in this case, over b, which is 5. Okay. And if I do that division, 160 divided by 5, I get 32. And now this is easy to evaluate because 2 to what power is 32? 2 to the 5th power. Okay, so that's one way to evaluate this by using the laws of logarithms. Okay, let's try another one. So suppose I want to evaluate this. Log base 2 of 6, log base 2 of 15, plus log base 2 of 20. Okay, so here I have subtraction going on and addition. So when I look up here at my laws, I'll be using this again. And I also have addition. So I'll be using that as well. Okay. All right. So I can write all of this as a single log, base 2. And what happens here is anything that's positive or addition, anything that's positive will be written as a multiplication. So that's 6. This one is positive and this one is positive. So that's going to be 6 times 20. But this one over here, this one is negative or subtraction. So that one will go down below, division. Okay, and then you can cancel this any way you like. We see that 6 and 15, they have 3 in common. And then we see 5 and 20 have 5 in common. So then here, this becomes log base 2 of 8. And that's easy to do because 2 to what power is 8? And that would be 3. Okay. So we're going to be practicing. So if these are like, wait, I'm not sure, I don't really see that. We're going to practice using the laws in a second here. So, but what you're doing here is you're trying to figure out which of those laws can you apply. Like if you see a subtraction, you're going to use that law number 2. If you see exponents, like right here, you know you're going to use law 3. And if you see a combination, addition, and subtraction, like you do right here, you're going to be using 1 and 2, laws number 1 and 2. Okay. So laws 1 deals with addition and multiplication. Law number 2 deals with division and subtraction. And law 3 deals with exponents. Okay, so let's practice using those and maybe it'll make a little more sense. Okay, so we're going to be taking a look at it. We're either expanding or condensing. Okay, that's what we're doing. Okay, so let's take a look. So let's do expanding first. All right, so let's go ahead and expand the following. Now, if we take a look at our laws, let's go back to the top here. So we take a look at our laws here. The left-hand side, these guys, these 3 on this side, those are all condensed. We have a single log. But all of these on this side, on the right-hand side, all of these are expanded. Okay, so when they say expand the following, you want to try to write it as a sum or a difference or a multiplication with a sum and difference. When they say condense, you want it to look like the left-hand side, single log. Okay. All right, so let's take a look. So if I have log base 2, 3x. Okay, so here I have multiplication. I have a single log, so it's already condensed. So I want to expand this. So this one is multiplication. So this one is going to become addition. Multiplication and addition go together. So you would get this. Okay, and that's all there is to it. Let's have a look at this next one. Log base 5. Suppose that I have a multiplication. So we know we'll have addition in our answer. And then I also have a division. Okay, so you'll have an addition for the top, and then you should have a subtraction for that denominator. Okay, so we're going to have log base 5, 4, and then that w is also in the numerator, so we'll have plus log base 5 of w. And then that y is down below, so that one is going to have the subtraction. So it's going to be minus log y. Okay. So what the properties are basically saying when we look at something like this is that anything in the numerator will be positive and anything in the denominator will be negative or subtraction. Okay. So let's take a look at this one, log base 3. So we have z in the numerator, which means that's going to be a positive. We have a 2 down here. That one will be negative. And we also have a w here. So that one's going to also be negative. Okay. Numerators will be positives and denominators will be negative. So when I expand this, the log z will be positive, right? And then the log 2, since that's in the denominator, that one will be negative. Oops, that's not base 2. It's base 3. Okay, so the 2 will be negative, and the w is also in the denominator, so the w will also be negative. okay, according to our laws. So hopefully that makes a little more sense as far as what's going to be addition, what's going to be subtraction. Okay, so let's take a look at this one, log base 4. And let's make it a little more interesting. Suppose we have a cubed, b squared, all over c d to the 4th power. Okay, so again, anything in the numerator will be positive, anything in the denominator will be negative, and it almost doesn't matter. It doesn't really matter what order you put them in, so long as the ones in the numerator are positive and the ones in the denominator are negative. Okay, so like if I decide to just mix them all up and not even go in any kind of order, if I do D4, since that one's in the denominator, that would have to be a negative, right? So, right? And if I decide to do the B squared next, well, that one's in the numerator, so that one will be positive. Do you see what I'm doing here? I'm trying to make my point. Okay, and then if I do C next, well, C is in the denominator, so that one needs to be negative. Okay, and then if I do A last, then that one's in the numerator, so that one needs to be positive. Okay, so again, it doesn't matter what order you put them in, so long as they have the correct signs. Okay, and now I'm going to apply the third law, which says, oh, okay, take all of your exponents and bring them down to the front. So that D4, the 4 can come down to the front. That b squared, the 2 can come down to the front. C doesn't have an exponent, it's understood to be 1. And then that a cubed, the 3 will come down to the front. Okay, do you see how that works? Okay, you can first figure out their signs, and their signs are dependent on where they are, numerator or denominator, and then bring their exponents down. Okay, so let's take a look at this one, log. And suppose that I have 5 times the square root of a. So remember here, if I don't see a base, no base means base 10. Okay. All right, so here, so this is just multiplication. This is just, they're both in the numerator because if you put them over 1, right? So they're both going to be positive. Log 5 plus log square root a. Okay, but what I want you to do, and I believe your homework wants you to do this too, turn any radicals into fraction exponents. So this is the same as saying log 5 plus log a to the 1/2. Remember, square root is the same as exponent 1/2. And then now you can use that third law, which says bring your exponents down to the front. 5 doesn't have one, it's understood to be 1. So I'll bring that 1/2 down to the front. So 1/2 log a. Okay, do you see how that works? Okay, let's try one more. Log. And let's do x times x plus 1 all over square root of x squared minus 1. It looks like it's complicated, but that's just an a times a b all over c. So it's really just 3 logs you should end up with. All right, so the top ones, x and x squared plus 1, those two will be positive. So log x plus log x squared plus 1. All right, so we're done with that one. And then the square root down below will be a negative log. And I'm going to go ahead and write that with a 1/2 exponent. All right, so now we've got all of our positives and negatives out of the way. I'm going to go ahead and use law 3 and bring that exponent down to the front. So this will remain the same. This one remains the same because we don't bring down this square to the front because we're taking the log of this whole thing, x squared plus 1. If the whole thing in parentheses had an exponent, then we could bring it down. But the whole thing, x squared plus 1, does not have an exponent. So we just leave that. And then this third one, the whole thing, x squared minus 1, does have an exponent of 1/2. So that's why we're able to bring it down to the front. Okay. And that's pretty much it for expanding. Okay, so let's have a look at condensing. We're going to go the other direction. So we're going to start off with something expanded like this. And our goal is to get it condensed to a single log like this, going from like maybe 3 logs over here to 1 single log. All right, so let's go ahead and have a look. Condensing. All right, so go ahead and let's condense the following. Okay, suppose that I have this log base 3 of 5 plus 5 log base 3 of 2. Okay, so we're going to go ahead and start off with these numbers over here out in the front. Okay, we're going to go ahead and move them back to the exponent position. Okay, so that log 3/5 will remain. But this one will become log base 3 2 to the 5th. Okay, so all I did was move that front number back to the exponent position. Okay, and both of these are positives. So I will just have 5 times 2 to the 5th. Okay. I don't have any subtractions, so I won't have anything in the denominator. All right, let's have a look at this one. Log base, that's base 10, no bases, base 10. So log 12 plus 1/2 log 7 minus log 2. All right, so we do have one number out in the front. That's this one over here. So let's go ahead and move that back to the exponent position. The others will remain the same. Okay, so once we move those front numbers back to the exponent positions, now we can go ahead and condense single log. And again, anything positive will go in the numerator. Anything that's negative will go in the denominator. So 12, log 12, that one's positive, so that goes up. Plus log 7 to the 1/2, that's positive. So I'm going to write that as square root 7. Okay. And then now we have a minus log. So that one will go down below. Okay. And if you want, you can reduce this. So log of 6 times square root 7. Okay. All right, let's try another one. suppose that I have this log base 2 of A plus log base 2 of B minus 2 log base 2 of C. Okay, so front numbers. Let's start with front numbers and bring them back up to the exponent position. Nothing in the first one, nothing in the second one. Right here, third one has a 2. So let's go ahead and bring that back up to the exponent position. So C squared. All right, now that we've taken care of the front numbers, now we can go ahead and condense. And we want to rewrite this using only one log. So there's my one log. And let's go ahead and figure out who is going in the numerator and who is going in the denominator. So all the positive logs will go in the numerator. So that would be A and B. And all of the negative ones would go down below. So that would be C squared. Okay. Okay, so let's go ahead and try this one. Log, oops, yeah. Log base 5, x squared minus 1, minus log base 5, x minus 1. Okay, so this is going to be more like what you are going to need to do when we're solving. You might get something like this. You know, might get something like log 5 x squared minus 1 minus log 5 x minus 1, and then equals 10 or something like that, right? Okay, and then you have to solve this. And that's where these laws, where you have to condense it, that's when it becomes crucial. Okay, so when we get something like this where we actually have to solve it, you will need to condense it first, and then you can solve. So let's go ahead and condense this. We don't have any numbers out in front, so we can go ahead and condense right now. And let's figure out who's going to go in the numerator, who's going to go in the denominator. All right, so that first one is positive log. So that's going to go in the numerator. And the next one is a negative log. So that's going to go in the denominator. And here I would just go ahead and simplify that, since the numerator can factor out to x plus 1, x minus 1, right? And I can cancel out now the x minus 1s, right? Difference of squares is x plus 1, x minus 1. And so now I can cancel those. And so my final answer is going to be log base 5 of x plus 1. Okay? This simplifying bit you might have to do on your homework. But if you get at least this far, like you're applying the properties correctly, if you get that far on the test, well, normally you would get most of the points. Okay, so make sure you do the homework and find out what the program wants you to do. If it'll allow you to keep your answer not simplified, x squared minus 1 over x minus 1, or see if it wants you to simplify, and keep track of that so that on the day of the test, you know which way it wants you to answer. Okay, let's take a look at this one. For log x minus 1/3 log x squared plus 1 plus 2 log x minus 1. Very important for you to really master these laws here, especially when we get into solving. Okay, so we have numbers in front of all of these logs. So let's go ahead and move them all back to the exponent position. So this will be x to the 4th. This one will be, that's a fraction exponent. So I'm going to go ahead and rewrite that as a cube root already, just to save myself some time. That's supposed to be a plus. Wait for it. There it is. And then this one, x minus 1 squared. Okay, so we took care of all the front numbers. So now let's go ahead and condense to a single log. All right. So anything that's positive will go in the numerator. So that first log is positive. So x to the fourth will go up here. That second log is negative. So that's going to go down below. Cube root x squared plus 1. Okay, because that one's the negative one. And then that last one, that third one, is positive. So x minus 1 squared will go in the numerator. Okay. And that's about it. Okay. Let me just do one more. Suppose that you have this 2 parentheses log 5x plus 2 log 5y minus 3 log 5z. So if you have this 2 on the outside, all you need to do is distribute this 2, this one right here. Okay, so distribute that 2 to all of the terms inside. So you would get 2 log 5x plus 4 log 5y minus 6 log 5z. Okay, all you did was multiply all the coefficients by 2. All right, now we'll go ahead and move those front numbers to the exponent position. So this will be x squared. This middle one will be y to the 4th. And this last one will be z to the 6th. Okay? And so then here, now that we have all our numbers moved back to the exponent position, I can go ahead and condense this, write this as a single log. And let's figure out who is going to be in the numerator, who will be in the denominator. We have a mix of positives and negatives here. So that first one, positive log x squared. That one's positive. It goes on top. The next one, positive log y to the 4th. So that one also goes up in the numerator. And now we have a minus log z6. So that one will go down below. Okay, and that is pretty much it for condensing and expanding. Okay, so again, it's all about knowing those properties. Okay, we have one last thing, the change of base formula. So if you remember in the last video, I talked about how on your calculator, how you only have log base 10 and log base e on your calculator, right? This one is just the log with nothing showing. And this one is the one that has the L and the N. This is what you have on your calculator, right? Okay. And so my question was, well, how are you going to evaluate like log base 2 of 5 or something like that, right? So that's where this comes in. So you only need 2 log buttons on your calculator, and you can calculate any log by changing the base. Okay? So we're going to use this for your calculator. Since only log base 10 and log base e are on it. Okay, those are the only 2 logs you have. Okay, so here's your formula. So if you're doing like log base 2, which is not on your calculator, right? Or log base 5, or log base 7, or log base any number but 10 and e. If you're using any any other base, okay, and you have to take the log of that. The way you do it on your calculator is by taking the log, any base you want. Well, you only have 2 on your calculator, so you're going to use that one. You're going to take the log of n and divide by the log of b. Okay, so you can do that on your calculator. Or, here, let me write or instead of equals. Okay, so or you could use your LN button and do this, okay? What it basically is saying is, so that's what you would do on your calculator right here, okay? Because you only have base 10 and natural log. But in general, what it's saying is that if you are taking the log and you have some base, you can change your base. That's why this is called change of base formula. You can change it to any base you want. So I'll call it A, any base you want. Okay. And that's supposed to be it, base A. Okay, you can change it into whatever you want, and you'll still get the same answer if you use this. Okay. But any base, you don't have any base on your calculator. So that's why I kind of simplify this idea or this formula to this. Okay, so let me give you an example. So here, I'm just going off to the side. You don't have to copy this. We know what this answer is, right? We know what this answer is, right? We don't need a calculator to figure that out. Log of 8 base 2. This answer is 3 because 2 to the third power is 8, right? Okay, so that's fine. It's more like, what if you have to evaluate this? Log base 2 of 7. Well, here, in this case, we're trying to figure out 2 to what power is 7. And, well, if we do 2 to the third power, that's 8, so that's too big. So then if I do 2 to the second power, that's 4, that's too small. So we know the answer is going to have to be somewhere between 2 and 3, okay? So if you punch this into your calculator, you don't have a base 2, so you have to use your change of base formula and punch in log or ln, either one. So either one is fine. Okay, of 7. Okay, I'll do both here, over the log of 2 or over the ln 2. Okay, either one is fine. Okay, so if you punch this first one, if you punch this in, and then if you punch this one in, compare your answers, they're exactly the same, okay, because it's a ratio. All right, and the answer that you should get should be an answer that's somewhere between 2 and 3, since 2 is too small and 3 is too big. Let me pull up my calculator. Again, don't forget to turn your calculator sideways so that you can get all of your scientific buttons. And here, so I'll use ln. ln 7 divided by ln 2. And I get a number between 2 and 3, just like we expected. And we get 2.8 0.07. Okay. It goes on forever, but I like 3 decimal places. Okay, so that's how you evaluate logs that are not base 10 or E. And that's all you have on your calculator, base 10 and E. Okay. All right, so that is it for 4.4. Again, if you have any questions, make sure you email me, especially now that we're getting closer to taking that first test. Okay. All right. You guys enjoy the rest of your day. Keep up with the homework.